Okay, so this is how to draw Lewis structures. The first step is to use the periodic table to figure out the number of electrons for each atom, and you can see in this chart over to the right that each group has a certain number of valence electrons, and it's not important to know the number for each atom, but rather the total. For step 2, you just write the atoms out using their symbol from the periodic table and then connect them using a bond, and a bond is written with a single line and it represents 2 electrons. And they're usually in order how they're written. So, for example, HNO is written with the H and the O connected to the N. For step 3, you need to make an octet for all the surrounding atoms, which means 8 electrons around the atom, but H is an exception because it only has 1 pair of electrons. For step 4, you draw if the number of electrons doesn't add up to the total number of electrons that you got in step 1, then you add the leftover electrons around the central atom. And then if the central atom still doesn't have an octet, you have to increase the bonds to either single or double to satisfy that, or even triple too. And then this is just a summary of all the 4 steps. So quickly you just do the number of electrons, then write the symbols and connect them with bonds, then make an octet for all the atoms, place leftover electrons around the central atom, and then if the central atom still doesn't have a satisfied octet, you add or increase the bonds. There's some things that are different for Lewis structures. If you can draw more than one, there will usually be one that is the most important or most dominant, and you can determine that by calculating the formal charge. And when you calculate the formal charge, the equations on the bottom, all non-bonding electrons are assigned to the atom they are around, and then the electrons in bonds are split in half between the atoms that are in the bond. And when you calculate this, the sum of the formal charges should equal 0 for neutral molecules, and it would equal the charge for an ion. So if you can draw several structures and they all have formal charges that add up to either 0 or the charge of the ion, then you should follow the rules listed here. And it says if the dominant structure bears atoms whose formal charges are closer to 0, that will be the dominant. And then if the structure with a negative charge on a more electronegative atom will be more dominant than those with negative charges on less electronegative atoms. So you can see over to the right the formal charges are calculated, and you can see that the Lewis structure on the left would be more correct because it follows rule number 1, which has atoms that are closer to 0 with their formal charge. Another thing that is an exception when drawing Lewis structures is the octet rule, and there can be 3 cases in which there is an exception, which is molecules or atoms which have an odd number of electrons, molecules or atoms that have less than an octet, and molecules or atoms that have more than an octet. Okay, so some molecules or atoms will have an odd number of electrons, and for example ClO2 has 21 valence electrons, so that needs to be shown in the Lewis structure. The next exception is when it has less than an octet, which means it will require less than 8 electrons to fill their outer shell, and boron and beryllium are the most common molecules that are an exception, and you can see over to the right that BF3 shows that B does not have an octet. More than an octet is molecules or atoms that can hold more than 8 electrons, and elements from period 3 and under are the ones that are able to do this due to their large size and unfilled D shells. And you can see over to the right that XeF5 has more than 8 electrons surrounding it.